Hello, everybody. It's nice to welcome you for yet another talk during our Java conference, because it's from Warsaw. Chairman shouldn't have his darlings. However, I'm a big fan of WebAssembly myself, so I'm very eager to hear what our next guest, Frank Lyaruu, I hope I pronounced it properly, have under his list. So, Frank, the mic is yours, the stage is yours, and we are waiting for your talk.
Hello, thank you, Arthur. So let's talk about some WebAssembly in Java today. I'll be talking about sandboxing a little bit. I will first introduce a little bit the concept of sandboxing, then I'll get into the technical details. I'm Frank Lyaruu. I'm a software engineer at ENG. I have done a lot of stuff in software, pretty much everything. I've been in the Java space for 25 years. Last few years, mostly Rust, and today I'm doing Rust and WebAssembly at ENG. If you're interested, I also do some embedded Rust tutorials on YouTube, so at Floodplain NL if you're interested. But for today, let's talk about sandboxing, application level sandboxing. Java itself has some history of sandboxing as well. I'll go through that. Then I'll introduce WebAssembly very briefly. It's all a lot to put in half an hour. Then I introduce Xtism. There's a framework to do that, and about writing and calling sandboxed code. So, sandboxing, what is that? Let's not start with the boring Wikipedia definition. Let's start with an example. And the OG example of sandboxing is an operating system. An operating system lets you do multiple things at the same time that kind of are separated from each other. Like that, if one thing breaks, it won't break everything. If it runs out of memory, that application gets killed, the others are fine. So that's kind of what it does. And also, every different application can have different access levels, so you can make sure nothing weird happens. So that's what sandboxing does in operating system. It wasn't actually always like that. Like if you're old enough like me, you'll remember something like Windows 95, where there was some level of separation, but if one process crashed, probably will take down your entire computer. So nowadays, pretty much every operating system has sandboxing, maybe except some embedded stuff. Now, since operating systems, we have added an extra layer. Containers. So containers are basically processes, but with some added stuff on top of it, most notably a virtualized file system. So not only are they separated in memory space, but they also have their own file system. And the same for the network stack. So that means that they can't get into each other's way in terms of file system or network stacks like a normal process still could. Another kind of sandboxing is a browser. Browsers originally had no sandboxing at all, but then again, originally they only showed static content. They were just a viewer of a static piece of data that you could link to another static piece of data. So that wasn't really necessary at that time. When JavaScript was introduced, again, if you remember, at first, you could switch it off if you didn't trust running untrusted code on your own machine. Made a lot of sense, but nowadays, maybe you can still turn it off, I'm not sure. But even then, like nothing would work anymore. So we kind of have to have some mechanism to separate it. And all browsers basically do. Every browser has some kind of sandboxing, so that one tab can't steal the data of another tab. If you're reading on one forum, you don't want it to get data from your banking application or something like that. And also, you don't want to separate it from your host system so that it can't reach your file system, at least not without a very good reason. And also what sandboxing allows is having sort of process management. So that looks a bit like this, that browsers can indicate like when a browser window or tab is misbehaving, taking too much resources, being too slow, or that you can just kill tabs at all, which would be really tricky to do reliably without sandboxing. So, in summary, sandboxing. denying code access outside the sandbox of every component, let's call it that. Manage stability, make sure that if something goes wrong, it doesn't propagate, and also manage the resource usage. So, but I'm not going to talk about that because I want to talk about application level sandboxing, because we are at a Java conference. We are not building operating systems or browsers here. We're writing applications. Is there a reason to put sandboxing there? There are a few, but I want to focus on one of them. And one of them is the notion of data gravity. And data gravity, in a nutshell, is the notion that data is hard to move. I mean, we do it all the time, of course. That's our business, moving data from A to B. But the more data there is, the heavier it is. It takes a lot of compute. It takes a lot of transmission costs. It takes a lot of energy. So if at all, I can't see myself anymore, but I guess it's okay. I'm going to continue. If there is if you need to move data, it's expensive. And conversely, moving code is often not that expensive. So let's look at the classic case. For example, here we have a classic case where we fetch some data from a system. Again, I still have no screen. I'm still hope it's okay. We have a system, a client that calls a server. The server returns some data and the client does some analysis. And then you have some kind of result. So you query maybe some REST or some other stuff. The server retrieves the data, returns all the data, and the returning of the data is kind of a big deal, right? Because you need to serialize it somehow, and then you need to encrypt it, compress it. On the other side of it, you need to decrypt it, decompress it, and deserialize it. So it's a big deal. And then the client does the analysis, and then you have a result. So what I would like to introduce here is the notion of edge computing, and that looks something like this. So there is analytics code on the client side, but the client asks the server to run that code for it. So the client sends the code to the server. The server queries the data, but also runs analytics code and then returns the result. Seeing that these arrows are much thinner, there's a lot less data to move around. And if we get this well, this is definitely less work for the client because it doesn't need to do the analytics anymore. But it could very well be that it's also less work for the server, because even though it's running the analytics, it's running it really close to the data. And that's a much cheaper thing to do than moving the data across the wire. So if we make a naive attempt to implement that using Java without any sandboxing, we can imagine some kind of filter that will say which document to include or not. Maybe you have a big set of documents and you want something really specific, but you can't really express it in a query or something like that. You just want to see all of them, and then you say yes or no. So filter document. You could implement that and then do whatever you need to do to filter that, and you could ship that binary or that class file to the server, and the server can run that, and that basically works. There's not something you see a lot, and that's for a good reason, because you can do all kinds of stuff. You can, in this case, maybe you can get all the system environment variables and send them somewhere. There's nothing stopping you. You have all the same privileges as the rest of the application. Or you can figure out another something else. You can read the file. If the application can read files and there are files to read, so can you. So that's a bit of a risk. You can mitigate it a little bit by indeed not sharing too much of the file system, maybe by putting it into a container, or maybe you can limit the exfiltration a little bit. But those are all a bit stopgaps, and you never know if you got all of them. Now moving from the evil ones to the maybe a bit of accidents. If you would make that filter and that somehow hot loops, so it just ends up in the loop and never leaves. That's a bit of an icky situation, because that's a thread that will be consumed basically forever, and it's really hard to get the thread back out of a situation like that. And then the request will just hang, and then at some point you'll need to restart the server to reclaim your thread. And that's a risk in itself as well. Maybe a bit more nefarious even like this one, that will start a thread. And that thread does something, but after it concludes, and it will just work, but that thread is still running. And that will just sit there somewhere in the memory of the server, and every time a request comes by, there's one more, and at some point the server will run out of memory and it will crash, and it would not be clear that this is what happened. And these are very, very simple cases, but generally, like if you use your imagination, the last one with the while true, it's usually not a while true, but it's some odd condition where it doesn't terminate. That can happen. Furthermore, like in this one, like maybe you have a third-party component that starts some notification threads you weren't aware of. Who knows, right? It's easy for this to happen accidentally. So in conclusion, running third-party code in your servers is a great idea in terms of data gravity and efficiency, and it's also a terrible idea in terms of security. So hold this thought for a moment. So there was sandboxing in Java a long time ago. There was a security manager that limited what you could do from a JVM, and it is kind of a similar use case. It was from the time that Java was used in applets, and it has been deprecated, but only pretty recently. It wasn't being used in years and years. But it is an interesting thought of what happened, because and if you know what happened or you have thoughts on it, please let it know in the questions. Yeah, it is odd to me that it kind of just vanished and there is no replacement. But it's an interesting article to read anyway. So leaving that aside, we have WebAssembly. WebAssembly is a technology that started in making high-end graphics in a browser. Generally, it's just to run code in a browser that doesn't want to be JavaScript. And that was the original point. And a lot of different implementations, like in Photoshop, Miro, I think, Figma, a few more, they use WebAssembly to run inside the browser. And the results are pretty nice. You can run some really nice code in a browser. But if we look at what WebAssembly brings to the table, so we're talking about high performance, we talk about for all the high-end graphics, we talk about the sandbox because it's in the browser, the resource manager the same, and it's also polyglot. So that means that WebAssembly is not a language. That's a common confusion. It's a compilation target. So you can compile many languages to WebAssembly. That's just a binary in a sense. That runs on a virtual CPU, sort of. So you can use different languages, and if it compiles to WebAssembly, whoever is running it doesn't care anymore which language it was, which is pretty nice. If we look at this, we can think, well, this can be really useful for our applications as well. Like, imagine we have a host application that has some like plugins. Plugin is not a very sexy word nowadays. There was a time there were a lot of plugins, like in the heyday of Eclipse and everything. But right nowadays we don't really talk about plugins. But I will do for this case anyway. And we can run a few services. We can run these services in different languages if we want to. If we run it in Go and C, in Kotlin native, there are a lot of options there, and they have that security part. So they can't step out of their service. If they overstep their boundaries in terms of resource management, we can do something about it. So that's the thought here. Let me introduce you. I probably you haven't heard of it. It's a framework called Extism, and that is a very polyglot framework that can run a lot of language from a lot of other languages. So there are two kinds of sides to it. There's the host application, so that can be pretty much any language, and then there is the plugin application that need to be compilable to WebAssembly. Not every language you can compile to WebAssembly. Sadly, one of those languages is Java, because, I mean, technically it's not impossible, but given that Java has a big runtime, has a garbage collector, you would have to compile all of that into WebAssembly, and that gets a little bit inefficient. But it's a nice way to get started. So let's look at a plugin. So that's a WebAssembly service. That's in this case it's Rust, but it's very simple. So even if you're not very aware, knowledgeable about Rust, you can figure this one out. So it exposes a function. You can see that with in the middle the plugin fn annotation that will say this function will be shared with the host application, so it can call it. It says count vowels, puts in a string, and returns a result. The result of a test output type, which we defined just before, and that is serializable, and it returns and it contains a count. So nothing too fancy. Next up, the host. Like if we have our Java application, how do we call that? Well, first of all, the Rust application we had before, this one, we need to compile it with a specific target, and then we end up with a file, and that's called count_vowels.wasm. That file, you can see that here. Here we open a manifest that points to that wasm file with a hash. That's not so important. And we just load that binary. And at this point, it does not matter anymore that it was Rust at some point. It's just a binary that has a sort of annotation with it that it says it exposes a function called count vowels, and it takes a string and it returns a string as well. I'll explain that in a bit. And then you instantiate the plugin with that manifest, and then you can call it, and then it will the plugin will create the service of the WebAssembly, and then you can call it. One big advantage of WebAssembly is that because it's a really lightweight, call it virtual machine, that it typically instantiating a whole space is a sub-millisecond. So it is much lighter than, for example, you could also resolve all this by invocating a new JVM somehow, but that's so heavy that nobody ever will do that. But in this case, yeah, we instantiate it and then we call it count vowels. And at the bottom, you can see what it returns. It returns a string because it returns JSON. Why does it return JSON? Well, it can return a lot of things, but one thing we need to deal with is that the types in Rust and the types in C and the types in Java are different. In Rust, I can return a string. It's not the same as a string in Java. So there needs to be conversion for that. And the way this example solves that is if we look at the Rust code, it says it is serializable. And because of that, in Rust, you can easily serialize it to a JSON file, which I don't know works, but it's not really anything specific, but it is something to take into consideration. So if we would implement this, how would that address our security issues? Because that was what we were doing, right? If we take our data gravity problem, we want to move code that we don't really trust from the client to the server, but that could do all kind of terrible things. Well, first, environment variable access. Well, that's not a thing because WebAssembly does not have a notion of environment variables. It's an operating system thing, and WebAssembly is in itself not aware of operating systems. File system access, same thing. You can give it access to the file system. You can see here with WASI in the middle. That's a parameter for the plugin. If you give it that, it has a limited access to the file system. You can really precisely specify for what, but if you say no, there is no file system access. And for a filter like this, there's no good reason to do that. So that works out. What else did we have? We had the hot looping thread, right? The while true thing. This one. Well, that's an interesting one. I think it's the most interesting one because if we look at our code, this one, the last parameter of the plugin, it says fuel limit. And fuel limit means how many instructions is it allowed to do on a single invocation. And after that, if it hasn't concluded by itself, it gets killed with a, I don't know, out of fuel exception. And that's a nice safety measure to have. Because, yeah, now it says 10,000. 10,000 assembly instructions is not a lot, by the way. Like for anything meaningful, you need to have a lot more than that. But it does terminate if you hang, and then you will at least know there's a problem and not slowly eat away all the resources of your system. The other one, the one where you keep on losing threads, that one is not really a thing either. First of all, because at the moment WebAssembly does not support threads, so you can't. But even if you did, it still would drink from the same fuel can. So if you leave a thread hanging, that too will run out of fuel at some point. So is it all amazing? Well, not all of it, but there are some issues. First of all, WebAssembly is like the next big thing, but it has been the next big thing for a long time. I talked about with Arthur before the talk. Yeah, is 25 going to be the year of WebAssembly? I think so, but I thought that before. So who knows, right? Second thing, getting data in and out of the sandbox is an expensive thing. It's not like a network connection kind of expensive, but still, if you end up having an application that moves a lot of data in and out of sandboxes over and over again, that's expensive. So you need to think about that. And also like how you do it. In this case, we were creating JSON and parsing JSON again. That's not the most efficient thing to do. But yeah, those problems you would not have without sandboxing. So it's something to keep in mind. WebAssembly has many standards. There are like the component model, which is really nice. That kind of specifies how types work, how you can transfer data in and out of a sandbox, which is nice, that makes the whole polyglot thing a lot easier, because otherwise you still have to agree on what a string looks like or an int looks like, if it's big endian, low endian, all those things, they all matter. There are also a lot of incubating standards that are not quite there, like the threads I mentioned before. There's also async ongoing, so you can run like code that will basically go to sleep and get notified and then continues again. And garbage collection is one of them too. The garbage collection would be really cool, because then that would allow garbage collected languages like Java to be a bit more efficient to run inside WebAssembly. There is a bit of support from Kotlin, which is also cool. I haven't tried it though. So Kotlin can have the capability to compile to native and by extension also to WebAssembly. So that might be something. And GraalVM has also some support for compiling to WebAssembly. I haven't tried that one either, though. So there is a little bit of mismatch between Java and WebAssembly, but it is nice that it opens the door to polyglot. You can say like, this is really compute intensive. I want to run that in Rust or something like that. And you can keep most of your application intact, but you can just outsource that little piece to a WebAssembly container. The final drawback, I think, is like, it's just not proven. Like, who knows what it's like to run a 10-year-old WebAssembly plugin application. Nobody does, right? And that's the same like with microservices. Like, now we talk about the drawbacks. We didn't talk about that 10 years ago because we didn't know. So that's something to be aware of. Well, in terms of takeaways, I think it's important to take the data gravity thing seriously. In my career, I've seen so much data being pushed around the world with no good reason, and so much that in the end, like, what we're actually doing is trivial for modern computers, but we end up spending thousands and thousands of euros a month in Amazon cost because we end up spinning up so many servers to push around the data. So think about that, right? Can we move the code to the data instead of the data to the code? Also, I think what's really nice is getting visibility of your performance, that if some part of your application is misbehaving, that you can see that and focus on that. It's a lot harder for a big system that just ends up being slow, and the wisdom will be, well, restart it every once in a while and it will be fine. Like, it really would be nice it's nice to see from different parts how they perform. I think it could be a good alternative to microservices. I think in many cases where we use microservices is because we want to do some polyglot sandboxing, not because we want to move data over the network all the time. So also to keep in mind, if you're interested, look in the WASM component model. It's really nice, and WASI has come a long way as well. And finally, I like that it is a re-evaluation of how we talk to the environment, in the sense that, like, if you run a process, it's basically the same process it has been for like 40 years. Like, nowadays we run so much on the cloud, on a function as a service, serverless kind of things, but we still kind of, in the container, we pretend it's running on a real computer, which is not true. So I like that one, but it's not very actionable. So that's all I got. So please leave some feedback. If you have any questions, I really like question and discussions. If you want to chat about this or maybe embedded stuff, reach out on LinkedIn. I'm easy to find. And I think Arthur is back again. So let's see.
And we actually have time for that. Okay, the question is from Michał. Can I start Xteam host on Android device? It would be interesting to download the WASM file and hash from the network and use Android device to perform distributed computing. Somebody want to do the botnet, I see.
Oof. Not sure. I think the Xteam uses a native WASM runtime. I think it spawns WASM time. So in order for Xteam to work, that needs to work. Not impossible, I guess, but I have a feeling it's not going to be easy. There are also JVM native, JVM based WebAssembly runtimes. I'm missing the name right now. Something with
Cherry
an
J? It was okay. I heard about it. Yeah, Cherry J or something like that.
Chicory.
Chicory. Okay, yeah.
Yeah, and it's from the same people actually who make Xteam. So that might be.
That.
So that might be easier. But all in all, I think it's non-trivial. Let's call it that.
Okay, so that's probably all. Thank you for the talk. Thank you, dear audience, for the questions, and see you on the next talk that is starting in 5
All right,
minutes.
thank you.
No, it's starting in 10 minutes actually, because we have 5 minutes of time. Okay, it's starting in 10 minutes. Okay, so thank you, Frank.
Right.
It was wonderful.
Thank you.